Hello, my name is Caleb Crump. Today I'll be talking to you about a few important distribution logistics tools, just a few that I believe are very crucial. Not all tools will be covered today, obviously, with as broad as the term covers, but yeah, let's get into it. Alrighty. What are distribution logistics tools? Kind of as a brief definition across the board for all softwares and tools that fall under that category. I've got software or tools implemented in the supply chain or warehouse to help improve efficiency and accuracy. Now, it can obviously improve other aspects of those supply chains or warehouses given the tool being used. But some potential reasons for implementing distribution logistics tools would be causes from things like today's high consumer demand. Um, Customers are online more than ever with cellular devices and internet access being as broad and wide as it is. And companies are advertising um, and taking advantage of all screens available, meaning that consumers are buying pretty frivolously but still expect to receive items at high quality and at quick turnover rates. Um, Another potential use for logistics tools could be warehouse errors. If you're having issues receiving products, shipping products, or storing any inventory, there are a wide variety of tools that can help optimize space as well as efficiency and accuracy for receiving and shipping and cut costs for any kind of errors that are being caused in those fields. Cost and efficiency, kind of just covered that with errors being made. That's obviously going to lead to loss of sales and loss of profit. So it may cost to implement these tools, but in the long run, it's likely going to be a far better use of your money than having a person do the job rather than a tool or software. Um, the tools we'll be covering in this presentation are going to be warehouse management systems, the Internet of Things, AI-driven analytics, as well as cloud computing. First off, I'm going to start with Warehouse Management System, or WMS for short. Um, it likely goes without saying that the original warehouse management system was carried out by individual workers or just regular people who kept detailed logs themselves of the data being handled. Um, it likely also goes to show that with everything being done by hand and by humans, there's going to be a substantial amount of errors. And with those errors is going to come a loss of money, a loss of profit, a loss of products. Could even come with safety concerns if data is not being taken in a correct manner or in important aspects like safety. Um, Due to those errors, it has obviously led to mechanical innovations that have been created to help mitigate errors and automate repetitive tasks so that we can take out that human worker and take out that cost for them to do such repetitive tasks. Um, it helps the business grow as well with as efficient and as accurate as it will become. Um, a few of those innovations include automated storage and retrieval systems. Um, it kind of it kind of is exactly as the name puts it. The automated storage and retrieval systems are implementing softwares and implementing machines or robots to do the job of the people that were previously doing these jobs. But with it being those automated systems and softwares and robots, the error rate is going to substantially decrease, leading to um, likely improved efficiency, so more products being moved through, improved accuracy, less errors being made, and uh, improved sales with as accurate and as efficient as it's become. Today's warehouse management systems are primarily just software solutions. They track inventory to keep up with warehouse inventory if things need to be auto ordered or things need to be maybe set aside if they're not moving efficiently, things like that. Order fulfillment, making sure orders are being sent out and received at the correct rate and they are the correct orders being sent out. Space optimization, so that the warehouses can make sure they're using all the space efficiently, as well as storing products and things like that in the best manner that they can. Um, Labor management for the workers that are still there. It's going to handle the likely the payment systems and the just general day-to-day systems for what the workers do or what they may need to do, dependent on the data that the system has taken in, and many more options. Alrighty. Next, we're going to go over the Internet of Things. Sounds like a pretty broad concept just to hear it, but it, generally speaking, did come along kind of with the advancement and creation of the Internet. The Internet of Things began as an idea in the 80s and 90s on a college campus that students created to keep track with soda inventory actually in a vending machine so that the students did not have to traverse campus to figure out if their favorite soda was in stock at the local vending machine. It's kind of funny that that's what it was originally brought up to when you fast forward to what it's used to current day. It's such a wide reach across the whole world and used for such substantial data. It's incredible. Um, Simply put, the Internet of Things is basically any device capable of computing connected to the Internet of Things and communicates data to and from that device's Internet of Things application via the Internet. So pretty much anything technological is connected to the Internet of Things. It's everything is always gathering some form of data, no matter what aspect that is, and that data is being collected and sent off somewhere to be used. It's not just going to be thrown away, and it's not just trash data. It's very useful for some company or some device out there, so they can monitor things and keep an eye on how things are going in real time. Industrial applications for the Internet of Things. This didn't really begin until the 2011, the 2010s, really, when technology and chips were put into industrial machines for predictive maintenance, meaning that it can take data from the machines, understand how the machine's acting and operating, and if there may be some sort of potential issue arising, that they can pause that machine, kind of turn it off before that issue arises, and save the money that they would have had to spend on like fixing that problem. They also implemented this in things like worker having to wear the technology in their vests, their hard hats, their just everyday safety equipment, just so we can make sure that they are being as safe as possible and they're being as protected as possible out there on the job. The IoT, Internet of Things, like I said, has a worldwide reach already. It's actually outnumbered the human population. It's been outnumbered since 2008. I think the current day Internet of Things devices, I think, is somewhere in the 10 billions, if not 20 billions worldwide. The reach is kind of incredible, really. In a similar internet kind of taboo pool, there is the cloud computing option. Cloud computing is a tool that connects users via the internet to a platform where they can pay for services based on usage for computing data. It's different from the Internet of Things, given that the Internet of Things simply takes in data and uses it for anything that they really need to, whether it's like updates to that device, preventative maintenance for the device, just keeping track of how the device is being used by the users, how they can better make that device better for the users. And this cloud computing option is where they connect to a cloud computing server via the internet and use that server to basically do exactly that, compute data. So it's a little different, but at the same time, quite similar to the Internet of Things. So it's good to just kind of differentiate the two. Um, the concept of the cloud began back in 1963 with scientists wanting to have two or even maybe three people accessing the same data at once. I can only imagine how that went in a big room filled with a large computer trying to access. Um, it's evolved quickly in 1969 with the invention of the internet and rapidly evolved in the industrial applications and just computing applications in general in the 90s when companies began to further understand exactly what the internet was and what the benefits of tools and softwares on it are. The three computing services offered with cloud computing is infrastructure as a service, platform as a service, and software as a service. They're all similar in that they offer a type of service. It's just what type of service that is, as you can tell. The infrastructure as a service offers just that, like IT infrastructure, networking, things of that nature. Platform as a service kind of just offers a platform for you to build data or to calculate data on. And software as a service offers you a base software to build data onto that software. So they're all similar in their own aspects, but just slightly different based on how you want to use them, or how you want to use your data, I should say. Um, Cloud data can be stored publicly, privately, or on a hybrid. Um, and I mean, it's quite easy to understand that one. You can either store it publicly, where the data is public knowledge, anyone can access it, as well as you can access their data if you're storing it on the same public server, or privately on your own server. Some companies even have their own servers in their physical basements, like on premises. But other companies typically like to use some sort of hybrid where they show you what they want you to see, but kind of hide what they don't want you to see, which, as you can tell, is probably the smarter move. Lastly, we're going to go over AI, artificial intelligence. It's a hot topic nowadays and kind of hard to not talk about it in almost any setting at this point, which is incredible. But AI and the supply chain management go as far back as the 1950s when scientists wanted to use computers to try and solve logistics, supply chains problems, even back then. Very simple problems, I should say, as to compare today, but my how it has advanced quickly. The different methods for the AI usage are typically traditional AI and generative AI. The traditional AI takes data and does one specific task. It's kind of what we're most used to, and a much more simple AI compared to something like generative AI. Generative AI takes the data or takes a language model, makes something completely new of it, and can even create something completely new from that. I mean, it takes language models and does what a human can do and optimizes things and better improves those models, but at a fraction of the time, at a fraction of the cost, and it's just incredibly hard to compete with if you're a person. Um, the typical use of AI in this industry is for things like broken supply chain or optimizing networks. If there's any issues in a supply chain or warehouse issue, you can likely incorporate AI in some way to hunt down exactly where that issue is, that bottleneck or that problem, and come up with a solution or multiple solutions to fix that problem. I think the market volatility is what I think the AI is most useful for, kind of like the predictive measures, in my opinion. AI can take data from current day, kind of use it to predict future model, whether it's for market volatility or for other aspects, but it can use that data to create future very accurate models for what the AI believes will happen. It can be used for safety concerns for drivers, truckers, make sure, or even warehouse workers, just making sure everybody's doing everything to the best of their ability. Um, all the jobs and all the aspects of the jobs are optimized and made as safe and as best for the worker as possible. Um, and it's kind of a backwards point to help reduce carbon footprint, given how substantial AI creates a big carbon footprint. But it goes back to those predictive measures where it can use those predictive data to kind of see how your business is currently working, um, what it's spending on transportation, what it's using on those kind of things that lead to a carbon footprint, and how it can mitigate those issues or reduce that footprint, even though the data centers used for the AI are creating such a footprint. I've also included a little quote here from Chris Caplice from MIT that I think really nails AI. Machine learning, AI, and generative AI are taking this large language model approach and solving what has been solved pretty well by operations research, but doing it faster, more completely, and solving it to non-traditional objective functions. Just showing that it's doing what we can do, um, just kind of giving humans a little nudge that it's not it's not putting us it's not putting us to bed, but it is definitely doing what we can do and doing it much better, much quicker, and even to a higher degree. So finally, I'd like to wrap it up with a little discussion on why use distribution logistics tools. If I haven't swayed you so far in this presentation, just one final piece for the tools that I've gone over. Um, Warehouse management can be useful for small and large businesses, though I will say if you're a small business and you don't have a warehouse or you're not moving products substantially, it's probably not for you. But if you are any kind of business receiving or shipping products, storing products, or even making products, that warehouse management system is going to do you a lot of favors. It's going to be much more accurate than a person could be, and it's likely going to save you a lot of money. It's a no-brainer for large businesses. They're obviously going to be able to afford it, and it's obviously going to make their operations even better. So large businesses are going to incorporate it wherever they can. The Internet of Things, I think, is in best practice at large applications, but just given that the data that it acquires in its use in any application, I think the Internet of Things is incredibly useful. Whether it's for machines, large machines in the industry, small devices, applications on devices, anything. It's the data that it acquires is priceless in my opinion. Um, Cloud computing is incredible for users given the pay-as-you-go aspect. You just pay for the data that you compute. If you're not going to have to substantially set aside a lot of money to rent servers or anything like that. You just hop on the server, use it for what you need it to, and pay for that use, which is incredible. Um, and it's also incredible given how easily it is to access both cloud computing and Internet of Things. You can get it anywhere in the world as long as you have access to the internet. But with cloud computing, it also gives you that option for whether you want to go public or private with your data, which is incredible. AI-driven analytics is incredibly useful, probably the most useful tool we've talked about today. It's widely accessible in today's world with as many AI out there, and they're creating more and more every day and just further improving on them. It's great for preventative measures, and like I previously talked about, I think it's most useful for predictive models, just seeing what the future may hold given how accurate it has been for those things. And it's obviously going to help with efficiency and accuracy, as well as incredible for machine learning and other learning aspects in general for your um, either warehouse or supply chain there, or just your industry that you're working in. And like I said in the beginning of the presentation, these are just a few of the tools. Some other popular tools are like transportation management services, material handling equipment. There's a number of tools that the industry puts to use um, in order to better help the consumers and better help their businesses as well. So yeah, it's in my opinion, the distribution logistics tools are incredible, and these four specifically are incredibly important. And these are my works cited. Thanks.